You'll recall from the previous segment that we had this program that is compiling normally. I'll recompile it, and is executing, except when I enter a number such as 9, the results are simply coming back as 0. The problem here is the scope of our variables. You'll recall that we've created a function prototype to pass and to accept 3 float variables. Our calling statement is passing 3 variables, number input, number squared, and number halved, and our calculate results function header is accepting these 3 variables. Once the calculations take place, then the answers of our calculations are then being stored, or displayed rather, in the main function. And this is where the zeros are coming from. The calculations are taking place, but yet when they are received back to the main function, they are retain the value 0. And this is why. We are passing these variables by value. Variables can be passed either by value or by reference. When you pass a variable by value, C passes only the contents of the variable. So when these 3 variables are passed to the calling statement, they are being passed by values and not by reference. What does this really mean? When you pass a variable by value, C passes only the contents of the variable to the receiving function. The receiving function does not have access to the variable in memory, so it cannot change the variable's contents. You pass a variable by value when the receiving function needs to know only the value stored inside the variable, but the receiving function does not need to change the value stored in the variable. You can also pass a variable by reference. When you pass a variable by reference, C passes the variable's address. In other words, its location in memory. The internal memory of a computer is like a large post office, where each memory cell, like each post office box, has a unique address. Because the variable's address, or location, is passed to the receiving function, the contents of the variable can be changed by the receiving function. To pass a variable by reference in C, you must include the ampersand, which is called the address of operator, before the corresponding formal parameter's name in the receiving function's parameter list. The address of operator tells the C compiler to pass the variable's address rather than its contents. You pass a variable by reference when the receiving function needs to change the contents of the variable, which is what needs to take place in our example program. Nothing needs to be changed in our calling statement. What needs to change is in our function prototype and also in the function header. Since the 2 variables that need to be changed are number squared and number halved, we need to place the ampersand after the word float in the second and third parameters respectively. It is important to place these in a one-to-one relationship. That is, this float refers to number input. Number input does not need to change, so therefore we are not using the address of operator. Number squared, however, does need to change. So in the function prototype, I'm including the address of operator. Likewise, for number halved, I've included the address of operator. Now, we need to do this to the function header in addition to the function prototype. So scrolling down to the function header, you'll note the actual names of the variables. The syntax requires the ampersand, or the address of operator, to precede the name of the variable in both cases. So I'll place the address of operator in front of the variable name that we want allow to change. Now let's recompile our program to see where we stand. Now it compiles normally, and we'll run the program. I'll enter the number 9, and as you can see, our program is again working correctly. As far as the user is concerned, the program functions in the exact same manner as our original program, except now we're making use of functions. You might wonder, well, why use functions? Why not just use the calculations directly into the main function? And in this particular sample, that might make perfect sense. But as programs become more complex, it becomes useful to create these so-called functions to allow to be called multiple times. And the result in in this example, we're only calling this one time. But I could call this function several times, and I can in fact pass different values to it each time. The more complex your C programs become, the more useful functions will become.